I am trying to convert this equation to a different format using FOIL. So, FOIL looks like this. What I'm going to do is I'm going to take the x and multiply by the x. So I put a little arrow like that. And that would give me, well, first of all, let's write f of x in front. But x times x is x squared. And I go x times 2, which is, hopefully you can understand, is 2x. Then I'm going to multiply this one times this one, negative 4 times x, and I get negative 4x. And then negative 4 times 2 gives me negative 8. Now, we just FOILed, but can we simplify that answer? Yes. So f of x, because that's what it says it's called, is equal to, well, does the x squared have something to combine with? No. But do you notice these have something to combine with? Yes. They combine. That would give us a negative 2x. And the negative 8 has nothing to combine with, so I am done. There we go. We went from intercept form to standard form. And it's right there. So this went to this called FOIL. Now, if you looked at this carefully, intercept form, do we know our zeros right here? 4 and negative 2, right? If you look at the graph on the other sheet, you see the 4 and negative 2. When I convert to standard form, now do I know my y-intercept? So if you ever need different pieces, you can convert it to find them. That is an option. For this one, we're going to convert this this is a vertex form. We're going to convert it. It's going to become standard form, just like this one. Now, do you guys understand that x minus 1 squared means x minus 1, x minus 1? Yep. So what I'm going to do right off the bat real quick is just write that. X minus 1, x minus 1. I'll hold off on writing the f of x for now. Now, just realize there's a minus 9 at the end. We're not going to lose. I'm going to write it there so we don't lose it. So now can we FOIL x minus 1, x minus 1? So watch what happens. That right there. Oh, I'm not going to FOIL. I'm going to do the box. Let me take that back. I'm going to do a box method. Just so you have a different method. You can do FOIL if you want. You can do FOIL if you want. This box method, basically, you make a box and you take each factor, each x minus 1 as a side to the box. And then we treat it like a multiplication table. So I'm going to multiply x times x, and then x times negative 1. It's like a multiplication table. And when you get x times x, you get x squared. When you take x times negative 1, you get negative x. We're just filling in like a multiplication table. You got negative 1 times x, you got negative x. Negative 1 times negative 1 is positive 1. So it looks a lot like FOIL. It's just in a box. It's clean. Organized for you organized folk who like that. Now, do you also see here how these combine? See how those are the same? So my answer for this piece right here, for this piece right here, don't forget the negative 9. Many of you, I think, might forget that. If we combine all this in the box, we get f of x equals, looks like x squared, and don't we get a negative 2x? And a positive 1, but don't forget about the minus 9. Please, a lot of you might forget that. That guy, you can't lose him. He's still hitting out here. And when we combine those, now we got an answer. So f of x is equal to x squared minus 2x, and 1 plus negative 9 is negative 8, which that matches that. See how they're the same? Which that's what we're looking for. So we went here again from vertex form to standard form. To change this notation, I'm going to use factoring. And watch what happens when I factor this. So, to factor it, I'm going to use my big X thing. I'm going to put the negative 8 on top and the negative 2 on bottom. And I got to think of two numbers that multiply to get negative 8 and add to get negative 2.
Negative 4 and 2.
Yep, hopefully you notice it's negative 4 and 2. So, my answer in factored form, first let's put the f of x is equal to x minus 4, x plus 2. There it is. Now that was an easy factoring. It could be anything. You might have to factor different kind of things. But if you ever want intercept form, you just factor it. This last one will take you the most work, completing the square. Completing the square is going to give us vertex form. So here's how completing the square works. What we're going to do, to start off with, is we keep the f of x. But we are going to group the x squared minus 2x, but we're doing a little thing here where, running out of space. Okay, ran out of space, but, all right, so what we're going to do here is we're going to fill in these blanks. So, let me make that more space right there. Oh, okay. Get it right there. Okay, good. So what I did is I grouped the x's, put a blank, and I pushed the negative 8 out, the minus 8 out, and put another blank. Now, what you have to realize here is if you have a equation or expression, are we allowed to add something and then subtract the same thing? If I have something like an expression sitting there, could I add 5 and then take away 5? Would that keep the same value? Could I add 8 and then take away 8? Did it really change anything?
No.
Are we okay with that? Now when we solve equations, aren't you adding stuff to both sides or subtracting stuff to both sides? But this one, what we're going to do, since it's on the same side, all we're going to do is we're going to add something here and subtract the same thing out here. And you'll see why in a second. Now to find this magical number that I put here, there's a process called in completing the square where you take this number, you are going to half it, and then you're going to square it. You always take the b value, you half it, you square it. That's going to take some remembering. That gives me negative 1 squared, which is 1. So I'm going to add 1 there and take away 1 there. So did I change the value of this expression? No, I just added 1 and took 1 away. Okay, great. But there's a reason it's going to show up why this is useful. Any questions with that? So now what we have to do is factor this front piece right here. We're factoring that. So to factor that, you can have 1 on top and negative 2 on bottom. When I factor that, it's going to be a perfect square trinomial. Negative 1, negative 1. It's always a perfect square. You'll see the numbers are always the same. So here's what we now have. We have f of x is equal to x minus 1, x minus 1. Got it? But what do we get when we add these on the outside? What's negative 8 and negative 1? Isn't that negative 9? Now, does anybody see vertex form right around the corner? Aren't these the same? Don't we want it to look like this right here? Doesn't it look very similar? Can't we write that as squared whenever you have two of the same? So I have now f of x equals x minus 1 squared minus 9. I just changed it to the vertex form. And the key here is that you got to be able to add, subtract this number. And then when you factor this, it always factors to be a perfect square. That's why I did this little process right here. It gives me a number so that I get a perfect square. And then I'll get vertex form.